Today's lesson is on introductions to quadratic functions. We've previously been looking at a few quadratic functions and we did not necessarily always recognize them. In our previous unit we worked with polynomials, and any polynomial with the highest degree of 2 was a quadratic function. Today we're going to look a little bit into the characteristics of quadratic functions, what they look like, and what are some important aspects of them. So first of all, we need to know that standard form of a quadratic function can be written as y equals ax to the second power plus bx plus c. We remember when we used to write the polynomials in standard form, it was in order from greatest to least based upon its degree, and that is how the standard form of a quadratic equation is written. A, b, and c just represent potential numbers. When it is graphed, a quadratic equation creates a U-shaped curve and is called a parabola. Looks like parabola phonetically, but you say it parabola. Types of parabolas. So there are two main types of parabolas for quadratic functions. They're either going to open up or open down. So it says to use your graphing calculator to sketch the following. So you could use your graphing calculator if you have one. If you're at home, you could also use Desmos. So you would just need to type this function into the calculator and let's see what it looks like. So this is our first one, the x squared plus 2x minus 5. So it has the U shape. It looks like a parabola like we just discussed. There are some key characteristics of a parabola. We need to notice that obviously it's a U shape. It has a bottommost point, which is actually called the vertex, and all quadratic functions are even functions, which makes them symmetrical. So what that means is there's always an imaginary line right in the center that if we wanted to, we could fold this function over and it would match perfectly. So it is symmetrical. We can fold these in half. So this little point at the bottom is the vertex, and this imaginary line where we would draw through here was called the axis of symmetry. You may have heard of that before. So if we're going to sketch this one on our notes, we need to kind of shift it over a little bit from the origin, and it needs to be going through. Looks like the imaginary line that it will cut through is at -1. It's always going to go through that x coordinate of the vertex. So on our notes, we would kind of shift it up over a little bit. We know that it's pointing up. This should be when x is a -1. And then the vertex here is at the point it said -1, -6. But we're always going to need to remember to put our little arrows on the ends, because this, just like a line continues on both ends unless told otherwise, so does a parabola. It will continue to go up. Alright, I didn't do a very good job of making it symmetrical, but do your best. It does need to match on both sides. Okay, so we'll take a look at the other one and just get an idea of what that looks like. So I already typed mine into Desmos, and this is what the second quadratic function looks like, the -x squared plus 3x plus 7. So this one has a vertex and it is a decimal, so that would be really kind of harder to show actually on the coordinate plane, so we're not really doing all that. We're just doing a rough sketch, but we do have this vertex here, and so technically the line where it would be cutting through in the middle, that axis of symmetry, would be happening when the x value is at 1.5. So on our notes, we're going to draw that it is facing down. It's just shifted over a little bit. This dot up here, this vertex, was happening at 1.5, 9.25. Didn't mean to put that there. And then this little line where we would be cutting it in half to fold over, also known as the axis of symmetry, is happening when x is 1.5. So we actually haven't learned the vertexes and axis of symmetry very well yet, but I just wanted to give you a preview of it because it's about to come up in a minute. But if we notice, when you graph the first one, it was facing up and the second one was facing down. So the big difference that you should notice between the two is that the number out front, even though we don't see one, there's some understood ones there. This value is the a value. Remember, y equals ax squared plus bx plus c. So that number out front, when it is positive, your parabola is going to open up like a smile. So the u is going to be facing up. When that a value is negative, the parabola is going to open down like a frown. So whenever the leading coefficient's positive, it opens up like a U shape. Whenever it's negative, it's down kind of like an N. So now let's talk more about the axis of symmetry. So we said that that axis of symmetry is the vertical line that divides the parabola into two equal parts. So it is that line where we have the parabola, it's that imaginary line where we would be able to fold it in half and it would match perfectly. So we remember that the equation of a vertical line is x equals a number. For example, x equals 5 is a vertical line going through the x value of 5. So all of these axis of symmetries are going to be an equation, x equals a number. Well, there is a formula to find that equation of the axis of symmetry given any quadratic equation. So that formula is x is equal to negative b over 2 times a. Now b and a are coming from the quadratic function. So in our y equals ax squared plus bx plus c, that's where this a and b are going to come from. They're going to come from the actual equation itself. The next piece of information is the vertex. So the vertex, I briefly pointed out to you when we first looked at our graphs, is going to kind of be that turning point. So it is the turning point of the parabola. Turning point of the parabola. So remember, we had, when it was facing up, we had a point down here where it changed places. When it was facing down, we had a point up here where it was changing places. So if the vertex is the lowest point on the graph, it is at the very bottom, it is called a minimum. It is the lowest value. If the vertex happens at the highest point, it is called a maximum. So I'm going to stop here and kind of talk a little bit more about this. We should be able to kind of tell whether or not a function is going to have a minimum or a maximum just based on the equation. If I have an equation and the leading coefficient is positive, so if I have a is positive, then that means that my graph is going to be facing up and it's going to have a minimum. If my leading coefficient is less than 0, so if it is negative, that means my parabola is going to be facing down and it's going to have a maximum value. So those are just some things to notice that'll help you move a little bit faster. So now we're going to do some examples of identifying this information with what we've learned. So for each of these, we're going to try and identify the equation for the axis of symmetry, the vertex, and then we are also going to sketch a rough sketch of the graph and identify the vertex and the axis of symmetry. Okay, so we know that the axis of symmetry comes from the x value in the vertex. So I'm going to use this axis of symmetry formula to try and find out what the x coordinate also is in the vertex. So we remember our formula for that was x equals negative b over 2 times a. So in our quadratic function right here, the number out in front of x squared is just a 1, so a is 1. The number in front of the x to the first power is 8, so b is 8. So I've got x equals negative 8 over 2 times 1. So when I reduce this, I've got a negative 8 divided by 2. So the axis of symmetry is going to be x equals negative 4, because a negative 8 divided by 2 gives us negative 4. Well, that is already our value for the x-coordinate in the vertex. So we already know it's negative 4 comma something. So now we need to find out what the y-intercept, the y-coordinate is for the point of the vertex. So we're going to find out what y is equal to when x is negative 4. So we're going to substitute in negative 4 to our original function here, everywhere we have an x, to figure out what the y-coordinate is. So y equals negative 4, make sure it's in parentheses, squared, plus 8 times negative 4 plus 15. So we've got negative 4 squared, which is a positive 16. 8 times negative 4 is going to give us a negative 32, plus 15. So when we work that out, we should come out with a negative 1. So y equals negative 1, which is our y-coordinate and the point of the vertex. So now we're just going to draw a little sketch. We know that since a is positive, our parabola is going to be facing up. Have our arrows on the end. Our point of a vertex is negative 4, negative 1. The line of symmetry, this axis of symmetry, happens at the equation x equals negative 4. And also we know that this is considered a minimum. The vertex is a minimum. So we'll try another one here. This time our a value is technically a negative 1. Our b value is 10. So finding the axis of symmetry, we've got negative b over 2a, so we've got x is equal to negative 10 over 2 times negative 1. So negative 10 over negative 2 is going to come down to a positive 5. So we know our axis of symmetry is x equals a positive 5. So now you are going to use that value to find the vertex. So we already know the x-coordinate is a positive 5. We're going to substitute in that x value into the function to find the corresponding y value. So we've got y equals negative 5 squared plus 10 times 5 minus 23. So 5 squared is 25, and there's a negative outside, so we got negative 25 plus 50 minus 23, and that's going to come out to be y equals a positive 2. So that is the y value in the vertex. So now for our sketch, this time the leading coefficient's negative, so we know it is facing down. So our vertex here is going to be considered a maximum. The point of the vertex is at 5, 2, and the axis of symmetry is going to happen at x equals 5. Alright, so we're going to actually skip down to number 7 because I want to give you a good mixture of examples, and the next few, 3, 4, 5, and 6, are all fairly similar. So we're going to skip down to number 7 because this is the first time where the quadratic equations start looking a little bit different. So it is still the same process. I'm still trying to find the axis of symmetry, and in this example, our a is negative 1, our b is 4. What's missing this time is the plus c. That's because it is a plus 0. We don't need that information right now, but that is what's happening there. So to find the axis of symmetry, again, it is negative b over 2 times a. So that is negative 4 divided by negative 2, which gives us a positive 2. So our equation for the axis of symmetry is x equals positive 2. That gets used in the vertex for the x-coordinate. Plugging that value into the equation to find the y-coordinate of the vertex, y equals negative 2 squared plus 4 times 2. So then that gives us negative 4 plus 8, which is a positive 4. So if y equals 4, that is the y coordinate in the vertex. Our sketch is going to be facing down because a is negative. So our vertex is considered a maximum. It's happening at the point 2, 4. And the axis of symmetry happens when x is equal to 2. Alright, so the next few here are similar. Number 8, x squared minus 3 is our equation. So this time the value that's missing is the middle term. So we can see that our a value is equal to a positive 1, but since our b value is missing, the only thing that it could be is 0. So when we plug that into the formula, negative 0 over 2 times 1, well, that's just 0 over 2, which is just 0. So axis of symmetry is happening at x equals 0. That's the x-coordinate of the vertex. When we plug that in, y equals 0 squared minus 3. So y is equal to negative 3. That is the y-coordinate of the vertex. The sketch, since a is positive, it is going to be facing up. So our vertex is considered a minimum. It's happening at the point 0, negative 3. And the axis of symmetry, the line that divides it in half, is going to happen at x equals 0. Okay, so I've given you several examples. I want you to work the remaining problems on your own. So we've got problems 3, 4, 5, 6, and 9. So that is 5 problems that I want you to work on tonight. Try them, bring them with you to class tomorrow, and we will check them for accuracy and discuss any confusion you might still have before doing some in-class practice.